All right, today we're doing LeetCode question 33, search in a rotated sorted array. So the question is saying there's an integer array nums, or there's an integer array called nums, and it's sorted in ascending order from low to high, right, with the distinct values. So prior to being passed to your function, your array nums is possibly left rotated to an unknown index, right? So for example, 1, 2, 4, 5, 6, 7 might be left rotated by 3 because you see 3 is missing, or by 3 indices, and become 4, 5, 6, 7, 0, 1, 2, right? So given the array nums, after the possible rotation and an integer named target, right? So we have a target here. So we're given an array called nums and a number called target. Return the index of target. If it is nums, oh, wait, if it's in nums, I'm so sorry. If it's in nums, return the integer target if it's in nums, or -1 if it's not in nums. Now, it's saying we have to write this algorithm in O log of n in the runtime complexity, meaning we cannot loop through the entirety of this array, right? If we want each value at a time, that is O of n, we are not allowed to do that, right? So let's take a look at the example, right? In example 1, you're given your array nums is 4, 5, 6, 7, 0, 1, 2, and your target is 0. Well, all we really want to do is find that value, right, and output it, the index. So that's going to be 4, right? 0, 1, 2, 3, 4, right? So now as we have an idea, like, okay, so we understand how this question is formulated. Let's take a look at example 2, just make sure we're all clear. Nums, the same exact situation like above, but your target is 3. There's no 3 here, so just return -1, which is what it says. If not, then -1. So we know that we are given an array, right, called nums. It's in ascending order, so we don't need to do anything. I don't need to sort. And we couldn't even because the time complexity doesn't fit for that. But we're given an array called nums, and we're also given an integer called target, all right? Or it would actually be an integer, and let's name this targets. There you go, right? And all we want to do is return the index or -1. So what pattern are we using for this question? Well, from what we've seen, we know that we cannot loop through the entirety of this list because of the rule requirement of the time complexity. And we know that we need to be able to cut that time in half in order to fit the O log event. The cutting in half should kind of give it away. We're going to be using binary search, right? And for people who are new here who may not know that, which is completely fine, binary search is basically a two-pointer technique. Two-pointer technique is when you have 2 values, right? Usually it's kind of the beginning of a list and the length of a list, right? So 0 and however many values are in this list. And you divide that by 2 to get the middle. Within the middle, you set rules and conditions to either go left or go right. This cuts the time in half, right? So you don't loop through the entirety, but instead, based off certain rules and conditions, you move left or right, and just you've reduced the time by 50%, right? So now as we have an idea of the pattern, how that's going to look is you're going to make a start, and you're going to make an end, you're going to make 2 pointers. Your start is 0, and your end is going to be the length of your array, -1, right? And then you're always going to do a while loop, right? So while start is less than end, boom. And then we're going to need a value, right, to hold basically your index, which we're going to call it middle. And all we're going to do is add, or start plus n divided by 2, right? And we do this because this gives you the absolute value. This just gives you decimal. We don't want that. So we do doubles, right? So this is basically our middle, right? Middle is our index. Beautiful. And then, if middle is our index and we already have a target, we could easily just, code up what happens if we get our answer, right? So what happens when we get our answer? Well, if nums, which is our array at index middle, which is our index, equals target, then return middle, right? So this is self-explanatory, right? You know, if we're in our list, right, at index middle, and let's say this was 7, then all we need to do is return middle because we found the answer, which is awesome, right? But what happens if we don't find the answer? And for instance, we need to, you know, go left or right. Well, this is what we're going to code up now. So let's say we want to check the left side, right? The left side. Well, keep in mind everything is sorted, right? So what we're going to do is check if the left side is sorted already. And if so, then that means we're gradually increasing, and we're going to go check that side. So we're going to check if nums at index start is less than or equal to nums at index middle. Keep in mind, because start is going to start from 0 initially, so it's going to be here, and then middle is going to be here, right? So in this instance, you see it's gradually increasing, which is great. If that's the case, right, this basically the left side is sorted, right? So if the left side is sorted, then we're also going to check if our answer is in between, right? In between the middle and in between the starting value. So we're going to start off with start, right? Because that's our first value. If nums at index start is less than or equal to nums at index target, or actually, no, I'm trolling it. Nums at, it's just target is less than or equal to nums at index middle, right? So this is saying if our answer is in between start and middle, then all we need to do is just check in between those values, right? So then we're just going to grab n, and this is a part of our binary search where we grab our value, and then we always make sure to increment by not just doing n plus or equals 1 or n minus equals 1 or whatever, but by using your middle value. So what this is doing is if it's in between, then we are going to, if it's in between, then we're going to go forward, right? Forward. If in between, right? Else, we are going to, if we're not doing that, okay, start then equals middle plus 1, right? Yes. Yeah. Okay. Cool. 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 So obviously, if this isn't the case, then we'll just do start equals middle plus 1, and then we can make an else here, and then obviously this will be the opposite. So this will be the right side is sorted, right? And this is kind of just vice versa. But before we go into that, let's take a look at the left side because this is really important. We're basically just be doing vice versa, or like copy and paste there. So it's important that we understand what we did right now. So nums are array, which is this. At index start, which is 0 in the beginning, if this is less than or equal to nums at index middle, which in this case is 7, right? It is. This proves that the left side is sorted. If we take a look, that's also true, right? 4, 5, 6, 7, right? It's gradually increasing and it's sorted. Beautiful, right? So if that's the case, then we're going to go and check these conditions. If nums at index start, right, is less than or equal to our target, right? And then our target is less than or equal to middle, which is the value over here, right? This would mean that our start and our middle, which is all the way here, and then and target is our answer, right? When we're checking if the target is in between. If this is not correct, right, and the target is not between, which you could see, or target 0, it is not, right? Then we would do n equals middle minus 1. Else, which is this is what does happen, you grab your start value, right, and you push it up, right? So now your start is not going to be equal to 0, but actually equals to middle plus 1. And this allows you to kind of just jump and check the right side, right? So beautiful. Now, as we have an idea, then we know if the right side is sorted or organized, right? We're going to check if target is in between, just like how we did before, right? So if nums at index middle, because middle would be our lowest value, because this is the right side, right? Is less than or equal to target, and then target is less than or equal to nums at index n. Oh, that's what's that? N, not an n, right? So this is checking if it's between. Then instead of doing n equals middle minus 1, we're going to do start equals middle plus 1, right? Else, right, if it's not in between, then we move backwards, right? Then we're going to do n equals middle minus 1, right? And this basically, every iteration of the while loop, these two conditions are being met until nums at next middle equals target and we return. Beautiful. But make sure it also says if that is not the case, we want to return -1, which that's why we're going to go out here outside the while loop and return -1. Because if we finish the while loop, that means none of these conditions were met. Primarily this one, meaning that we need to return -1 to show that the answer was not in there, right? And with that being said, we can run a test case or test result. Let's submit it, make sure we pass everything. And perfect.